The world is no longer just fighting over oil, land, or trade routes. It is fighting over something much smaller, the chip. For decades, semiconductors were invisible components buried inside phones, cars, factories, satellites, medical machines, weapon systems, data centers, and bank networks. Then the world realized that almost everything modern depends on them. Cars could not be finished because they were missing chips. Factories slowed down, consumer electronics became harder to produce. Governments realized that the most advanced technologies on Earth depended on supply chains, stretched across only a few countries, a few companies, and in some cases, a few buildings. The modern economy runs on semiconductors. Smartphones, computers, electric vehicles, cloud platforms, AI models, defense systems, missiles, drones, radar, satellites, and secure communication networks all depend on them. A country without enough chips is not just behind in technology, it is vulnerable. That is the real reason governments are spending so much. Chips are no longer seen as ordinary products that can simply be bought on the open market. They are strategic assets, like energy, food, steel, or weapons. The country that controls the most advanced chips can shape the future of artificial intelligence, defense, manufacturing, finance, and global trade. This is why the United States, China, Europe, Japan, South Korea, Taiwan, India, and the Middle East are all trying to build or secure their own chip ecosystems. They are not doing it because chip factories are easy. They are doing it because dependence has become dangerous. A single advanced chip can contain billions of transistors. To create it, companies need ultra-pure materials, extreme precision, specialized chemicals, clean rooms, advanced packaging, design software, skilled engineers, and some of the most complex machines ever built. The world's most advanced chips are concentrated in a small group of giants: TSMC, Samsung, Intel, Nvidia, ASML, AMD, Qualcomm, Broadcom, Micron, SK Hynix, and a few others. One company may design the chip, another may manufacture it, another may make the machines that manufacture it, another may supply the memory, another may provide the software tools, another may package everything together. The final product may look tiny, but behind it is one of the most fragile and valuable networks on Earth. The world is not just spending money to make more chips, it is spending money to reduce dependence on everyone else. For the United States, chips are about maintaining technological leadership. American companies dominate many of the most valuable parts of the chip industry, especially design, cloud computing, AI models, and high-performance processors. But much of the advanced manufacturing happens overseas. That creates a strategic problem. If America's most powerful technology companies depend on foreign factories for advanced chips, then its digital future depends on supply chains it does not fully control. So the United States is trying to bring more manufacturing back home. New fabs are being planned and built, billions in subsidies are being offered. Companies are being encouraged to produce chips domestically. The goal is not to make every chip in America. That would be unrealistic. The goal is to make sure the country has enough advanced manufacturing capacity to protect its economy and its national security. For China, the chip race is even more urgent. China is the world's manufacturing superpower. It builds electronics, electric vehicles, solar panels, batteries, telecom equipment, and countless products that depend on chips. But in the most advanced semiconductors, China still depends heavily on foreign technology. That dependence became a weakness when export controls limited China's access to some of the most advanced chips and chip-making tools. For Beijing, this was a warning. A country can build factories, ports, and cities, but if it cannot build the chips inside the machines, someone else still controls part of its future. So China is spending enormous sums to develop its own semiconductor industry. It wants domestic design, domestic manufacturing, domestic equipment, domestic materials, and domestic talent. It wants to reduce the risk that foreign restrictions can slow down its AI ambitions, military modernization, and industrial strategy. Europe sees the same danger from a different angle. It has world-class engineering and some critical companies, but it does not want to be trapped between American technology, Asian manufacturing, and Chinese demand. So Europe is also investing in semiconductor production, hoping to secure supply for cars, industrial machines, defense systems, and future technologies. Japan and South Korea are investing to protect their positions in materials, memory, equipment, and advanced manufacturing. Taiwan remains one of the most important places in the global chip supply chain because of TSMC, the company that manufactures many of the world's most advanced chips. Taiwan is a critical node in the global economy. If advanced chip production there were disrupted, the effects would spread through phone companies, cloud platforms, car factories, defense contractors, AI labs, and financial markets around the world. But building chip factories is not like building normal factories. A modern semiconductor fab can cost tens of billions of dollars before it produces a single chip. It needs years of planning, enormous amounts of water, stable electricity, specialized workers, and equipment so advanced that some machines cost hundreds of millions of dollars each. And even after the fab is built, success is not guaranteed. Making advanced chips requires yield. That means producing chips with as few defects as possible. At microscopic scales, even tiny errors can ruin a chip. A company can spend billions on a factory and still struggle to make chips profitably if the process is not good enough. Money can build a factory, but it cannot instantly create decades of expertise. The semiconductor industry was built through specialization. One region became great at manufacturing, another at design, another at equipment, another at materials. The system became global because no single place could do everything best. Now governments are trying to reverse parts of that globalization. They want local supply chains, local factories, local talent, local resilience. But the local resilience costs money. A chip made domestically may be more expensive than a chip made in the most efficient global hub. A new fab may need subsidies to compete. A country may spend billions just to reduce risk, not necessarily to make the cheapest product. The world is paying a massive premium to make sure it is not helpless if supply chains break. AI does not just need ordinary chips. It needs massive numbers of advanced processors, GPUs, accelerators, high-bandwidth memory, networking chips, and data center hardware. Training large models requires enormous compute. Running them for millions of users requires even more. This has turned chips into the fuel of the AI economy. Oil powered the industrial age. Chips may power the intelligence age. This is why NVIDIA became one of the most important companies in the world. Its GPUs became the engines of the AI boom, wanted by cloud companies, startups, governments, and research labs. When demand for compute explodes, chip suppliers become central to the entire economy. AI also needs memory from companies like SK Hynix, Samsung, and Micron. It needs advanced manufacturing from companies like TSMC. It needs chip-making machines from ASML. It needs packaging, networking, power systems, cooling systems, and data centers. The winners of this race could shape the next century. If a country controls advanced chips, it can build stronger AI systems, smarter factories, more advanced weapons, better medical tools, faster networks, and more powerful companies. If a company controls critical chip technology, it can become a toll gate for entire industries. The first risk is overspending. If every country builds chip factories at the same time, the world could end up with too much capacity in some areas and shortages in others. Not every fab will be profitable. Not every subsidy will create a global champion. The second risk is duplication. When countries try to build everything at home, they may spend more for less efficiency. The global chip industry became powerful because it was specialized. Rebuilding pieces of it everywhere could make the system more expensive. The third risk is geopolitics. Chips are now part of trade wars, sanctions, export controls, military planning, and diplomatic strategy. The more valuable chips become, the more political the industry becomes. The fourth risk is that technology keeps moving. A fab built today may be world-class now, but behind in a decade. Chip making never stands still. The industry demands constant upgrades, constant research, constant investment, and constant talent. The world is not spending trillions on chips because it knows exactly what the future looks like. It is spending because no country wants to be locked out of that future. If AI becomes the next major platform, chips will be the foundation. If electric vehicles dominate transport, chips will be the nervous system. If defense becomes more autonomous, chips will be the brain. If factories become smarter, chips will be the control layer. If data becomes the world's most valuable resource, chips will be the machinery that turns data into power. This is why a tiny piece of silicon has become one of the most important battlegrounds on Earth. The chip is no longer just a component. It is a strategic weapon, an economic engine, a geopolitical pressure point, and the hidden foundation of the digital world. The countries and companies that control chips may control who gets to build the future. And somewhere inside clean rooms, behind sealed doors, under light so precise it can carve patterns smaller than a virus, one of the biggest questions of the century is being decided. Is the world building the foundation of the next technological era? Or is it spending trillions in fear of being left behind?